Hello, guys. Welcome to Ramta Solutions. Welcome to your Organic Molecules series. Today's lesson focuses on aldehydes and ketones. This is all you need to know about aldehydes and ketones. So, how is the video structured? So, we are going to begin with what really makes aldehydes and ketones. Then we proceed to the individual homologous series, aldehydes. What are aldehydes? We will look at some basic properties of aldehydes, then look at the naming of aldehydes. Then the second part will be what are ketones? Here we're going to look at the basic properties of ketones. It makes ketones. Then how do we name ketones? To conclude the video, we're going to draw structures and name the structures of your aldehydes and ketones. Okay, so without any waste of time, let's begin. So, what are aldehydes and ketones? These are organic molecules, guys, that have a carbonyl group as a functional group. You remember, carbonyl group is carbon bonded to oxygen, double bonds. Okay, otherwise, generally, you find them like this, where this R could be alkyl group or hydrogen on both ends, depending on what you're looking at. If you're looking at an aldehyde, it'll be H on one side and the other side being alkyl group, or the other side could be, or both sides could be hydrogen atoms. But if it's ketones, both sides will be alkyl groups of the same or different sizes. It doesn't matter. But let's not worry about that for now. Let's look at the individual homologous series. So we're gonna start with aldehydes. So aldehydes, we saying that homologous that functional group can have hydrogen on both sides or hydrogen and an alkyl. So let's just get into it. So here is it. Do you see this? It has hydrogen on one side and the other side could be an alkyl group that extends to however you like. Then the suffix of your aldehydes is Al. Okay, of course, naming them like your alkanes, but the suffix is Al. Okay, and the simplest is methanol. We are going to draw the structure of methanol later. Okay, we are going to draw the structure of methanol later. Yes, you see the double bond here. This will therefore tell you that it seems like the general formula must exhibit that of an alkene, isn't it? Must exhibit that of an alkene, but it has an oxygen. So let's see. The general formula of aldehydes is CnH2nO. The CnH2n, doesn't it look like that of an alkene? It does, right? So aldehydes are made from or through the oxidation of primary alcohols. You know what are primary alcohols? We have a video on that, which was the previous video we uploaded, isn't it? And by virtue of them having this alcohol, even though it's not a hydrogen bond, by virtue of them having this oxygen, by virtue of them having this oxygen, even though it's not it will not have hydrogen bonding, it'll make aldehydes to have boiling points higher than alkanes of the same size. Okay, they will have boiling points that are higher than alkanes of the same size. Okay, but of course they don't have a hydrogen bonding, so boiling points of aldehydes will be lower than alcohols of the same size. Okay, with regard to their solubility, another point to mention is that the small aldehydes, which are those with 1, 2, 3, or 4 carbons, they are soluble in water. Okay, and these ones, they are also gases at room temperature. Okay, they are also gases at room temperature. And by the way, Um, Aldehydes are more reactive than ketones. We're going to understand this factor later on in a video that looks at properties of our organic molecules. Okay, great. So, what are the uses of our aldehydes in our perfumes? If you can look at your perfumes, your cologne, by the way, your cologne, if you can look at your perfume, no, I shouldn't say cologne. Yeah, your perfumes, not cologne. Your perfumes. Okay, I don't know if you have eau de parfum or eau de toilette, but if you can look at your perfumes, these bottled ones, and you look at their ingredients, you will find aldehydes there. Remember, aldehyde, the name ends with AL. Okay. Oh, yeah. Then you can also find aldehydes in our flavoring. For example, here we used caramel essence, right? You have aldehydes, or they use aldehydes. Then in the dye stuff, they also use aldehydes to produce our dyes. In pharmaceuticals, they are also using aldehydes. Okay. Now, how do we name aldehydes? Honestly, this of saying the naming is the same as alkanes is wrong. Sorry guys, it's copy and paste. So as is the case when we sorry, as is the case when we name organic compounds, we recognize the functional group. In this case, the functional group is the carbonyl group, isn't it? Then you find the longest continuous carbon chain, that is the maximum number of carbons possible. All right. Then you number your carbons beginning with the carbon of the carbonyl group. Okay. So with aldehydes, it'll be easy because it moves from the carbon to the carbonyl group. I mean, the carbon of the carbonyl group to either leftwards or rightwards, one direction only. So with that, it becomes easy, and you will see that later. Okay. Then, of course, you name each substituent that you have. Then the name, by now, you know that you begin the name with the number or the location of the substituents in your compound, right? And you know that when you have more than one substituents, different kinds, you list them in alphabetical order. And again, if you have substituents of the same kinds, you may use prefixes di, tri, tetra, and so on. Okay. All right. Because this is like the sixth or fifth video on naming organic compounds, we will not really focus on these things. I believe by now you guys know alkyl groups, all right? Okay, so let me just move. Same applies to the halogens. I will not focus on them. Now let's get to ketones. So ketones, their functional group is still the carbonyl, but now the carbonyl extends on both sides in alkyl groups. Okay, both sides of the carbonyl will be an alkyl group, and their suffix will be one. Okay, their suffix will be one, and the simplest is what we call propanone. Otherwise, ladies, you know it as acetone. Otherwise, ladies, you know it as acetone. Okay, guys, remember what I said to you. For ketones, they extend the chain extends on both sides. None of the R's is hydrogen, okay? This R for ketones represents alkyl groups, okay? Sure. Now, they have the same general formula as your aldehydes, okay? Ketones have the same general formula as aldehydes. And we can say they are produced through the oxidation of secondary alcohols. You remember aldehydes were produced through the oxidation of primary alcohols. Now ketones are through the oxidation of secondary alcohols. Okay, through the oxidation of secondary alcohols. Okay. Now proceeding Hmm. Their boiling points, I must say, they are higher than alkanes of the same size, which is a fact, but lower than alcohols of the same size, which is a fact as well. Right? And they have the same properties of your aldehydes, which are they are soluble in water. The small ketones are soluble in water and are also gases at room temperature. Remember, the small ketones, we're referring to those ones with one carbon to three or four carbons. These are your small ketones. How do we use them? In painting, we use ketones. To produce paints, we use ketones. Remember, to produce dyes, we use aldehydes. To produce paints, we use ketones. All right? Tanning, now this is when you convert your animal skins to, or animal hides to your leather. All right? Tanning makes use of ketones. Okay? The production of explosives is also making use of ketones. Right? And the production of lacquer, for example, for coating your wood, is also an application of ketones. Okay. Now, how do we name our ketones? Our ketones, the way that we name them, obviously, just like any organic compounds, we recognize a functional group. All right. Then you find the maximum number of carbon atoms or the maximum number of carbons in your chain. Then you number your carbon atoms. Where do you begin now? Now, with this one, you begin with the end nearest the carbonyl group. Okay. You begin with the end nearest the carbonyl group. Okay. Remember, with aldehydes, you begin with the carbonyl group. But with ketones, you begin with the end nearest the carbonyl group. And all other rules from this point onwards are the same. You name your substituent. You begin numbering the name of your compound to begin with the number of your substituent. Where is your substituent pointed? What is that substituent? Just like that, isn't it? Then, when you have two or more substituents, you list them alphabetically in alphabetical order, right? And if you have of the same kind, you will use prefixes di, tri, tetra, and tonin, and so on, isn't it? Just like that. So you guys will see this. I cannot wait to start. I cannot wait to start drawing and naming structures of aldehydes and ketones. So the naming, guys, as you can see, it's roughly the same for all compounds. As long as you recognize your organic, your functional group, you are good to go. Okay. All right. So our substituents, I'm not going to look at them. Now let's draw. I'm going to draw one. The first one that I'm going to draw is this one here. And what do we call this one? Oh, one carbon. We call it meth. Um, it is a carbonyl, and when I look at it, it has a hydrogen. So it means the name will end. Maybe let me not do this. Let me just say, oh, come on, buddy. Erase, please. Maybe let me do it like this. It's better. I think it's better. Let me just say it is. Right. It's better. So when it's like this, what do you say? You then say, okay, it means you will be a al. Right. It means you will be a al. Right. You will be a al. So one carbon is meth. So it's methane, but because it's carbonyl with a hydrogen, it is methanal. Do you guys see it? Carbonyl with a hydrogen, carbonyl with a hydrogen, it is methanal. Now let's try this one here. I'm going to make it complex now. What is this one? This one, let's see. We're gonna start numbering. We start numbering with the carbonyl. 1, 2, 3, 4. So what is this? Ooh, 4 means bute. Now we have carbonyl with a hydrogen. What does it mean? It means the suffix is -al. What is the name? The name is butanal. The name is butanal. Now let's draw the condensed structural formula. Let's draw the condensed structural formula. I want to draw the condensed structural formula. It is, if you like, I'm going to start at the bottom. It is CH3, CH2, CH2, and then CHO. Guys, please pay attention to the H and the O here. It is not OH but HO. This is to say it is a carbonyl. So the rule is to write it as HO to differentiate it from hydroxyl HO. Remember, with hydroxyl we say OH, right? With the hydroxyl we say OH. So for this one we say HO to separate it from the hydroxyl OH. Okay, please pay attention to this. All right, perfect. So this is butanal. Now let's try a last one. The last one will be, let me draw it here. It will be when you see, let me see here, then here, then here, and then here. So what do we call this one? First thing first, let's begin by numbering 1, because we start numbering at the carbon. We do recognize that this is hydroxyl with an H, therefore it is an aldehyde which ends with the name al. Right? So longest chain 1, 2, 3. So 3 means we have prop. Alright? We have prop, so propan. Alright? Then we also have a substituent here. Do you guys see it? We also have a substituent at number 2. So this then becomes 2 methanol, 2 methyl propanal. 2 methyl propanal. Do you see this? This is an alkyl group at carbon number 2. So this is 2 methyl propanal. What is its condensed structural formula? Its condensed structural formula will be CH3, CH open bracket, CH3, and then CHO. Happy? This is the condensed structural formula of your 2-methyl propanol. Okay? All right. So we are good. So this is basically how you name your aldehydes. Then let's maybe start with ketones. We said the simplest ketone was propanol. All right. We said the simplest ketone was propanol. Let's throw it. Prop. Not propanol, man. Propanon. Propanon. Prop. Or prop. Yeah, prop means 3. ONE implies this is this guy here. Okay? It is this guy here. So I will say 1, 2, 3. Now remember, because it's a ketone, right? Because it's a ketone, it'll have longest chain on both sides, right? Or it'll have alkyl group on both sides, isn't it? So how many carbons do we have here? 3. And where is the functional group? on carbon number 2. Of course, it cannot be on carbon number 1 or carbon number 2. Hence, we can call it propanone without really indicating the direction of the carbonyl group for this particular molecule. Okay, so this is propanone or propanone. Okay, propanone. Okay, now what is its condensed structural formula? CH3, CO, and CH3. Happy? Great. Now let's try another one. So remember, guys, with ketone, it's important that you specify the direction of your carbonyl group. Let's try this one here. It's going to be CH3, CH2, CO, CH3. Let's see now. With what I am seeing here, we have 1, 2, 3, 4. 4 would imply we have bute. All right? And I see we have carbon with a double bond. All right? Because there's no hydrogen, there's no other thing. So this will therefore mean it's a ketone. Therefore, the name ends with ONE. Now let's start. 1, 2, 3, 4. And then, okay, 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 okay. Hydrogen, 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 hydrogen. What is the name of this molecule? 1. The direction, the location rather, of the carbon is on the second carbon, right? It's on the second carbon. So we will say this is propan 2, okay? We can say this is propan 2, 1, or simply 2-propanol, okay? Or simply 2-propanol, okay? Or simply 2-propanol, okay? Or simply 2-propanol. You guys see it? Perfect. Now, let's try another one. I think we have 3 more. So let's try another one. 3-methyl, 3-methyl butane 2, 1. Ooh, let me go back. This is not propanol, it's bute, guys. Oh, no, it's bute. So my bad, guys. It's bute. It's bute. So butane. All right, it's butane. So it's butane. So it's 2-butanol. Sorry, I said 4 is bute, but I went with prop. Okay, moving on. With this one, let's begin now. 2-butanol. So bute means 4. 1 means you have a carbonyl at carbon number 2. So let's go. 1, 2, 3, 4. 1. And carbon number 2, that's when you have a buta and a carbonyl. All right. At carbon number 1, you don't have anything. And then at carbon number 3, that's where you have methyl. At carbon number 3, that's where you have methyl. Right? Do you guys see this? 4 carbons. At carbon number 2, that's where you have your carbonyl group. Carbon number 3, that's when you have your methyl. What is the condensed? The condensed structural formula. The condensed structural formula is CH3, CO, CH, open bracket, CH3, CH3. this is 2-methyl butane 2,1. Okay, otherwise it can also be called 2-methyl 2-butanol. Okay, 2-butanol. Happy? Perfect. Now, let's try two more, maybe. Now, let's try this one here. I'm going to use a condensed structural formula. CH3, CH2, CH2, CO, CH2, 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 and then CH3. Let's see. We start numbering from the left or the right. Let me begin with the left. Let me begin with the left. 1, 2, 3, 4, 5, 6, 7, 8. 8 means we're gonna say oct or octane, isn't it? And then, but I see now we have a double bond. This means we will have a ketone, right? Ketone with suffix 1 at which carbon? 1, 2, 3, 4, or 1, 2. Okay, 4. Let me not number from the right. But if you are numbering from the right, it's going to be 1, 2, 3, 4, 5. So better with the left. Okay. Now, this is easy because looking at this, you're like 1, 2, 3, 4, 5, 6, 7, 8. And then they're like, okay. And the fourth, oh, I wish I can leave them like this. But each up. Right? And what is this? This is octane 8 1, or simply 8 octanol. Okay, or you can call it 8 octanol. Okay, you can call it 8 octanol as well. All right, happy? Great stuff. Okay, perfect. Now, who can we try another one? Yeah, let's try one last one. It's gonna be a ketone as well. So let's draw it in this way. I don't know how it's gonna be. Let me put a double bond here. Oh no, let me do this. Let me do this. Let me add a CH3 here. Oops. Let me add a CH3 here. Just to make it interesting, guys. Right, just to make it a bit messy. Come on. Okay. Now let's proceed. What do we call this? Remember, you begin numbering with the end nearest the carbonyl. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 5. Okay. It's 5. 5 means pent. Right? I see a carbonyl. So what is this? It's a ketone, right? It's a ketone. And then ketone, it means the suffix is A-O-N-E. But where is it? It is at, where is it? It is at carbon number 3, isn't it? It is at carbon number 3. And then a substituent, methyl. Why is it at carbon number 2? Remember, you can say carbon number 2 or carbon number 5, but you always want your substituents to have the lowest number. So we're going to start numbering from the left to the right. So what is the name of this molecule? It is 2-methyl. Okay, it is 2-methyl. What is the longest chain? Pent. 2-methyl pentan, at which carbon? 3, 1. Okay. 3-methyl pentan 3. Sorry, 2-methyl pentan 3, 1. Right? Pentan 3, 1. Isn't it pentan 3, 1 or pentan 3 on? I don't know how do we say this, but I will say pentan 1. Otherwise, you can say it is 2-methyl 3-pentanol. Okay. It is 2-methyl 3-pentanol. Let me just write it. Or 2-methyl 3-pentanol. Okay. And this is it, guys. We have come to the end of our lesson on aldehydes and ketones. Okay. And with this being said, remember, if you would like to get in touch with us, visit our website www.aramtasolutions.co.za. And because you're watching on YouTube, in the description of this video, you will see links to all these social media platforms. Okay, so with that being said, ours ends here. But remember, the next video is carboxylic acids. And with that being said, let us say enkosi, asante, thank you, rolibuwa, re a leboga bagaetsho. Bye bye.